Scientists have just confirmed what locals feared all along. The floods tearing through Cebu haven't just exposed homes and roads, they've exposed something far more dangerous. 1 minute ago, new satellite data revealed the full extent of a fault line that's been hiding beneath this island for over 400 years. The ground that 5 million people call home isn't stable. It never was. And what we're seeing now, the collapsed buildings, the sinkholes swallowing entire streets, the families fleeing their homes in the middle of the night. This is just the beginning, because the earth beneath the Philippines has been keeping a secret. A secret that's now written in cracked concrete, flooded neighborhoods, and satellite images that show fractures running deeper than anyone imagined. It started on September 30th, 2025, at exactly 21:59 Philippine time. Most families in northern Cebu were settling in for the night when the earth beneath them began to tear apart. A magnitude 6.9 earthquake ripped through the sea floor 12 kilometers off the island's eastern coast, sending shockwaves that would forever change how we understand this region's geology. Within seconds, the shaking reached a devastating intensity 7th on the Philippine earthquake intensity scale. In the coastal town of Bogo, buildings that had stood for decades pancaked like accordions. Roads split open, creating chasms that swallowed motorcycles whole. In San Remigio, families were crushed in their sleep as concrete roofs collapsed without warning. By dawn, 79 people were dead, and over 200 lay injured in hospitals that were themselves damaged by the tremors. But what scientists discovered in the aftermath of that terrible night was even more alarming than the immediate destruction. The earthquake had awakened something called the Bogo Bay Fault, a name that didn't exist in any geological textbook before September 30th, because no one knew it was there. For over 400 years, this massive strike-slip fault had remained completely hidden beneath layers of sediment, coral deposits, and the accumulated debris of centuries. The violent shaking that night carved a 1.5-kilometer surface rupture that became visible from space, like a scar suddenly appearing on the face of the earth. Dr. Renato Solidum, the director of PHIVOLCS, described the discovery in terms that reveal the profound unease among the scientific community. This fault was completely unknown to us. Our geological maps showed nothing in this area. It's as if the Earth was deliberately hiding its most dangerous secrets. The initial assessment suggested the fault extended about 20 kilometers beneath the sea floor. Concerning but manageable within the context of Philippine geology. The country sits atop one of the most seismically active regions on Earth, where the Philippine Sea Plate grinds against the Eurasian Plate in a constant slow-motion collision that has been reshaping these islands for millions of years. Then came the floods. Typhoon Kalmegi, known locally as Tino, slammed into the already shattered island in early November. With maximum sustained winds of 185 kilometers per hour, it was classified as equivalent to a Category 3 to 4 hurricane. The storm brought torrential rains that turned streets into rivers and transformed the earthquake's cracks into channels for devastating floodwaters. At least 210 people died nationwide, with 109 of those casualties occurring in Cebu province. Before the island could recover, Super Typhoon Feng Wang, called Uwan locally, followed the same destructive path. This Category 5 equivalent storm brought winds that stripped roofs from buildings the earthquake had left standing, and floods that reached levels not seen in the region since Super Typhoon Ruping devastated the area in 1990. The rushing waters didn't just destroy what the earthquake had left standing, they strip-mined the landscape, carrying away centuries of accumulated sediment, topsoil, and debris. Roads were scoured down to bedrock. Hillsides were carved into new valleys. And most significantly for the geological community, the flooding stripped away the natural camouflage that had hidden the true extent of the Bogo Bay Fault system. PHIVOLCS scientists studying post-flood satellite imagery made a discovery that sent shockwaves through the geological community. The fault system they had initially mapped at 20 kilometers actually extends between 35 and 60 kilometers beneath the island. The flooding had revealed geological features, offset stream beds, linear valleys, disrupted coral formations that indicated a fault system of truly massive proportions. Dr. Maria Antonia Bornas, a senior science research specialist at PHIVOLCS, put the discovery in stark terms. The flooding essentially gave us a free geological survey that would have taken years to complete. Unfortunately, what it revealed is that we've been living above a time bomb that's much larger than we ever imagined. But that revelation was only the beginning of a much more terrifying pattern. The Bogo Bay Fault operates as what geologists call a dextral strike-slip system. This means that when it ruptures, the ground on either side of the fault slides past each other horizontally, like two massive slabs of concrete, grinding against each other. Most crucially, the majority of this fault system lies underwater, making detection nearly impossible until the moment it decides to move. The September 30th earthquake generated so much force that it permanently altered the coastline of northern Cebu. Satellite measurements show that some coastal areas were lifted by a full meter, while others dropped into the sea. The village of Danbantayan, near the earthquake's epicenter, now sits noticeably higher above sea level than it did before that night. Residents
ang
describe having to
pagbangon ng
climb down
probinsya.
to reach fishing boats that they used to access at ground level. Since that first violent rupture, the Bogo Bay Fault has refused to return to sleep. As of November 12th, 722 aftershocks have been recorded, ranging from barely perceptible magnitude 1.4 tremors to jarring magnitude 4.8 events that send families running from their homes. The strongest aftershock, a magnitude 5.8 tremor that struck on October 13th, injured 14 additional people and collapsed buildings that had survived the initial earthquake. What makes these continuing tremors particularly unnerving is their unpredictability. As recently as November 11th, just yesterday, a magnitude 4.2 aftershock struck near Bogo at 3:47 in the morning, jolting thousands from sleep and serving as a reminder that this fault system remains dangerously, actively unstable. But the discovery of the Bogo Bay Fault reveals something far more disturbing than a single, hidden geological threat. It represents the fourth major unknown fault to cause catastrophic damage in the Philippines over just the past decade. Each of these disasters followed an identical pattern: massive destruction caused by fault systems that didn't appear on any geological map, survey, or monitoring system. The 2012 Negros earthquake killed 71 people and displaced thousands more. Scientists had never identified the fault that caused it. The 2013 Bohol earthquake, with its magnitude 7.2 destruction that claimed 222 lives, struck from a completely unmapped fault system. The 2019 Zambales earthquake that damaged hundreds of buildings was caused by yet another unknown fault. And now, the Bogo Bay Fault has revealed itself through catastrophe. Dr. Solidum explained that these hidden faults exist because the Philippines sits at one of the most geologically complex intersections on Earth. The Philippine Sea Plate, the Eurasian Plate, and the Indo-Australian Plate converge in this region, creating what geologists call the Philippine Mobile Belt, a zone of constant tectonic activity where new faults are being created even as older ones shift and evolve. The problem, Dr. Solidum noted in a recent interview, is that these fault systems can remain completely dormant for centuries, even millennia. They become buried under sediment, overgrown by coral, hidden beneath cities and farms. From the surface, there's absolutely no indication they exist until they move. The flooding that followed the Cebu earthquake did something unprecedented in the history of Philippine geology. It performed what amounts to a massive, involuntary archaeological dig, stripping away layers of concealment and revealing geological signatures that would normally require years of expensive surveying to discover. Streambeds that had been mysteriously offset for centuries suddenly made sense when viewed as evidence of ancient fault movement. Linear valleys that had seemed like natural features were revealed to be fault traces carved by prehistoric earthquakes. Most disturbing of all, the post-flood surveys have revealed evidence that the Bogo Bay Fault connects to other underwater fault systems, a network of geological fractures that could stretch for hundreds of kilometers beneath the central Philippines. If these connected faults were to rupture simultaneously or in sequence, the resulting earthquake could dwarf anything in recorded Philippine history. The seismic monitoring data tells a story of an Earth that's anything but stable. The continuous stream of aftershock shows stress patterns that indicate the Bogo Bay Fault is not simply releasing energy and returning to dormancy. Instead, the data suggests that the September rupture may have transferred stress to other parts of the fault system, parts that remain hidden beneath the sea floor, waiting for their moment to move. Yet what comes next could make everything we've witnessed so far look like a preview. The ground beneath Cebu has betrayed its people before. In the pre-dawn hours of October 15, 2013, residents across the Visayas region were awakened by a sound that many described as the earth screaming. A magnitude 7.2 earthquake had erupted from the island of Bohol, just 70 kilometers southeast of Cebu, unleashing destruction that would kill 222 people and damage thousands of structures across the central Philippines. Like the Bogo Bay Fault, the fault system that caused the Bohol earthquake was completely unknown to science before the moment it ruptured. No geological survey had identified it. No monitoring system tracked its movement. No hazard map included its location. It existed as a hidden threat beneath one of the most densely populated regions of the Philippines until the moment it decided to announce its presence through catastrophe. Elena Rosario, a 67-year-old grandmother from Tagbilaran City in Bohol, still speaks about that October morning in whispers. The ground moved like ocean waves, she recalls, but waves that could kill you. My house was there when I went to sleep. When the shaking stopped, it was just gone, crushed flat, with my neighbor's roof sitting where my kitchen used to be. The Bohol earthquake generated a surface rupture over 6 kilometers long, a massive scar across the landscape that remains visible today. It created landslides that buried entire villages and triggered tsunami waves reaching 4 meters in height. But perhaps most significantly for the current situation in Cebu, the 2013 earthquake damaged buildings and infrastructure across northern Cebu province. The exact same region now struggling to recover from the September earthquake and November floods. Historical records reveal that this pattern of hidden faults causing unexpected devastation stretches back over a century. In 1948, a magnitude 7.8 earthquake shook the entire Visayas region, causing widespread destruction that older residents still remember in fragmented stories passed down through families. That earthquake, too, came from a fault system that had given no prior warning of its existence. But it's the more recent disasters that provide the clearest and most chilling preview of what northern Cebu might face in the coming months and years. Survivors from the 2013 Bohol disaster describe a terrifying progression of events that mirrors what's happening in Cebu today. The initial earthquake struck without warning, collapsing buildings and killing dozens in the first moments of shaking. But the secondary effects, the landslides triggered by aftershocks, the infrastructure failures that left communities isolated, the psychological trauma that lingered for years, proved to be even more destructive than the earthquake itself. Maria Santos, a teacher from Carmen, Bohol, describes the months following the 2013 earthquake. Every little tremor sent us running. My students couldn't concentrate because they were always listening for the next shake. We had aftershocks for months. I'm strong enough to knock you down. You never knew when the ground might move again. The parallels to northern Cebu's current situation are haunting. The ongoing aftershocks, the families too afraid to return to their homes, the children who wake up crying because they felt the bed move during the night. The psychological scars of living above an unstable earth often prove more lasting than the physical damage to buildings and roads. What's particularly disturbing about the historical pattern is how quickly these geological disasters fade from public consciousness. Within 5 years of the 2013 Bohol earthquake, development had resumed across the region with minimal consideration for the geological risks that had been so violently revealed. Housing subdivisions were built on ground that had visibly moved during the earthquake. Infrastructure was reconstructed using the same methods and materials that had failed catastrophically just years before. The collective amnesia seems to extend to government planning as well. Investigation into the flood damage in Cebu has revealed that $17.4 billion worth of flood control projects built between 2016 and 2025 failed completely during typhoons Kalmaegi and Fungwang. Many of these projects were allegedly constructed with substandard materials or never built at all. Phantom infrastructure that existed only on paper, while real communities remained vulnerable to disaster. The residents of northern Cebu are now living through a terrible echo of the 2013 Bohol disaster. But this time, the flooding has added a new dimension of geological vulnerability that didn't exist during previous earthquakes. The combination of seismic instability and water saturation creates conditions where the ground can fail in ways that haven't been seen in recorded Philippine history. And now, as aftershocks continue to rattle the region and new weather systems approach from the Pacific, scientists fear that history is not just repeating itself, it's amplifying. The situation on the ground in northern Cebu today reads like a real-time catalog of geological nightmares unfolding in slow motion. More than 70 sinkholes have opened across the region since the September earthquake, and that number continues to grow with each passing day. These aren't small depressions that might swallow a motorcycle tire. Some are large enough to engulf entire vehicles, and all of them appeared without any warning. The sinkholes are a direct result of Cebu's underlying geology. Much of the northern part of the island sits atop karst terrain, limestone bedrock that has been slowly dissolved by groundwater over millions of years, creating an underground network of caves and voids. The September earthquake fractured this already weakened foundation, and the subsequent flooding has saturated the limestone, creating conditions where the ground can collapse at any moment. In the municipality of San Remigio alone, over 100 sinkholes have been documented since the earthquake. Residents describe hearing a low rumbling sound, like distant thunder, in the moments before a new sinkhole opens. Children have been forbidden from playing in yards where new cracks appear daily in the soil. Families sleep in shifts, with someone always awake to listen for the grinding sounds that precede ground collapse. Former Mines and Geosciences Bureau geologist Dr. Al Pasion issued a stark warning just 3 weeks ago. Continued rainfall could trigger massive sinkhole collapses throughout the region. His words proved prophetic when a sinkhole opened beneath a section of the main highway connecting Bogo to Cebu City, forcing traffic onto smaller roads that themselves show signs of instability. The flooding from typhoons Kalmegi and Fenghuang has made the sinkhole threat exponentially more dangerous. Water has penetrated deep into the limestone bedrock, lubricating fault planes and creating hydrostatic pressure that pushes against already weakened cave ceilings. Every new rainfall event now carries the potential to trigger multiple ground collapses simultaneously. Local authorities have established emergency evacuation centers for 588 families whose homes now sit atop demonstrably unstable ground. These aren't temporary measures. Geological surveys indicate that some areas of northern Cebu may remain unsafe for habitation for years, possibly decades. Entire communities that existed for generations may need to be permanently relocated. The human cost extends far beyond the immediate casualties. The earthquake initially displaced 753,993 people across the affected region. The subsequent typhoons affected another 4.1 million nationwide, with hundreds of thousands still living in temporary shelters and evacuation centers across the central Philippines. These numbers represent shattered communities, broken families, and an entire region's way of life permanently altered by forces beyond human control. But the statistics don't capture the psychological toll of living above unstable ground. Dr. Carmen Reyes, a trauma psychologist working with earthquake survivors, describes a new form of anxiety she's observing in her patients. They've lost trust in the most basic assumption of human existence, that the ground beneath your feet is solid. Children refuse to sleep in beds because they associate lying down with the feeling of the earth moving. Adults check constantly for new cracks in walls, new sounds from beneath the floor. They're living in a state of constant vigilance that's unsustainable over time. The continuing aftershock sequence adds another layer of uncertainty to daily life. Since September 30th, residents have experienced an average of more than 9 aftershocks per day. Most are small enough to feel but not damage buildings. But several times each week, a stronger tremor sends families running from their homes, uncertain whether this will be the aftershock that triggers another major collapse. Weather monitoring stations are currently tracking another potential cyclone approaching the Philippines from the western Pacific. Long-range forecasts suggest it could reach typhoon strength and follow a path similar to Kalmegi and Fenghuang, potentially bringing more devastating floods to areas where the ground has already been compromised by seismic activity and previous inundation. State seismologists continue to record aftershocks daily, with the most recent significant event occurring just yesterday. Each tremor, regardless of magnitude, has the potential to trigger more ground collapse in areas weakened by flooding and previous seismic activity. The combination of ongoing fault movement, water-saturated soils, and approaching weather systems creates a scenario where multiple disasters could cascade into something far worse than anything the Philippines has experienced in recorded history. Emergency response teams remain on constant standby, but they acknowledge the limitations of their capability. Search and rescue operations become impossible when the ground itself can't be trusted to support the weight of heavy equipment. Medical facilities struggle to function when aftershocks regularly disrupt power and water systems. Even the evacuation centers themselves sit atop the same unstable geology that has forced thousands of people from their homes. Because what happens next in Cebu could fundamentally rewrite our understanding of disaster risk in one of the world's most geologically active regions. The most unsettling truth about the Bogo Bay Fault system is how much remains unknown, even after 2 months of intensive study by some of the Philippines' most experienced seismologists. Scientists have confirmed the fault's existence, mapped its surface expression, and documented its capacity for destruction. But the most critical questions about this geological threat remain unanswered, and the answers may determine the fate of millions of people living across the central Philippines. How deep does the Bogo Bay Fault extend into the Earth's crust? Does it connect to other major fault systems beneath the Philippine Sea? When will it move again, and with what magnitude? Dr. Solidum from PHIVOLCS has acknowledged that these questions may remain unanswered for years, possibly decades. Fault systems like this one can remain active for months or even years after a major rupture, generating damaging aftershocks without warning. But they can also return to dormancy for centuries. We simply don't have enough data to predict which scenario we're facing. Other geologists offer conflicting assessments that reflect the fundamental uncertainty surrounding previously unknown fault systems. Some argue that the September earthquake released the majority of accumulated stress along the fault, suggesting that the system may return to dormancy relatively quickly. Others point to the continuing aftershock sequence and the fault's apparent connection to other underwater systems as evidence that the most dangerous period may still lie ahead. Dr. Carla Dimalanta, a structural geologist at the University of the Philippines, offers perhaps the most sobering perspective. The discovery of the Bogo Bay Fault tells us that our geological maps of the Philippines are fundamentally incomplete. If a fault system this large could remain hidden until the moment it ruptured catastrophically, how many other hidden faults exist beneath our cities, our schools, our homes? The pattern of unknown faults causing major disasters suggests that the Philippine archipelago harbors geological secrets that current science cannot detect or predict. The country's position at the intersection of multiple tectonic plates creates conditions where new faults are constantly forming while older systems evolve and migrate. Traditional geological surveying methods, studying surface rocks, measuring small ground movements, analyzing historical earthquake patterns, prove inadequate for detecting faults that remain buried beneath sediment and seawater. The flooding that exposed the Bogo Bay Fault has revealed another dimension of uncertainty that extends far beyond geology. Climate change is intensifying typhoon activity in the western Pacific, with warmer ocean temperatures providing more energy for storm systems to develop and strengthen. This means that future floods could be more severe and more frequent, potentially triggering seismic activity on fault systems that have remained stable for centuries or millennia. The interaction between climate-driven flooding and seismic instability represents uncharted territory for disaster science. No computer models exist to predict how water saturation might affect fault stability in karst terrain like northern Cebu. No historical precedents show what happens when multiple typhoons strike an area already weakened by major earthquake damage. Scientists are essentially learning in real time as these cascading disasters unfold. Residents of northern Cebu now face impossible decisions that no human beings should have to make. Do they rebuild homes and businesses in communities that might collapse again without warning? Do they relocate their families to other parts of the Philippines that might harbor their own hidden geological threats? How do you plan for a future when the ground itself cannot be trusted? The Philippine government has allocated over $16 billion in recovery funds for Cebu province, but money cannot eliminate the fundamental uncertainty about what lies beneath the surface. New building codes can be written, stronger materials can be used, better monitoring systems can be installed. But none of these measures address the core problem. We don't know where the next unknown fault will reveal itself, or when it will choose to move. Children who survived the September earthquake and November floods will carry psychological scars for the rest of their lives. But they will also grow up with a knowledge that previous generations in the Philippines never possessed, an acute awareness that the earth beneath their feet cannot be trusted, that the solid ground of daily existence can disappear in seconds without warning. These children will become adults in a world where geological uncertainty has become a permanent condition rather than an abstract possibility. They will make life decisions: where to live, whether to have children, how to plan for the future, with the knowledge that massive hidden faults could be sleeping beneath any location they choose to call home. The Bogo Bay Fault may have been exposed by flooding, but it has revealed a truth that extends far beyond the shores of Cebu. We are living on a planet where the ground beneath our feet holds secrets that only reveal themselves through catastrophe. And in the Philippines, those secrets are still being written in real time, in the continuing aftershocks that shake northern Cebu, in the sinkholes that open without warning, in the families who sleep in cars because they can no longer trust their homes. The earth remembers everything, but it shares its memories only when it chooses, and always through destruction. Stay informed, stay prepared, and never forget that the earth beneath us holds more secrets than we'll ever know.